All right, we're still in section 7.1. This section is really all about angles. We've been talking about a bunch of things with angles. But there's a few things near the end of this section that are introduced that we're not going to use a whole lot later down the line, but they're really important to establish and learn about, at least at some point. So we're going to take this opportunity to learn about two things: arc length and area of a sector. And then in the next video, we're going to talk about speed. But okay, arc length. The idea of arc length is its distance along a circle measured like this. I mentioned this idea when I was talking about radian measurement and how it's unitless. Okay, I mentioned this notion of measuring like a distance along a circle. Traditionally, we use the letter S to represent arc length along a circle. So if that's S, if this angle inside here is called theta, for this video we're going to use theta instead of T. Those are sort of often interchangeable. The textbook kind of switches back and forth between them for some reason. But for this video we're going to use theta for our angle. And then the radius of the circle here we're going to use R. So we've got some circle centered at this point, and there's an angle there at the center of the circle. And these rays coming out from the center are intersecting the circle, and we're talking about the length of the arc along the circle. Well, what I told you in a previous video when I was talking about radians is that in radians, that angle theta is equal to the ratio between the arc length and the radius. That is how that is defined. So if you can figure out what theta is in radians, then it's gonna equal S over R, which gives us a formula. S, the arc length, multiply both sides by the radius here, and you get S equals R times theta. So that is the main formula you need to remember for arc length. It's how you calculate arc length in terms of the angle and the radius. So for example, if you have, say, theta is 36 degrees and the radius of the circle is 10 meters, let's calculate the arc length along the circle that you're going to get when you have a 36-degree angle and a radius of 10 meters. So first of all, that angle is in the wrong unit. That's in degrees. This formula requires that theta must be in radians. Let's put like several exclamation points on that. That theta must be in radians in order for this formula to work, right? Because it all comes from the definition of radians as ratio S divided by R, right? So when I calculate my arc length, S, I'll take my radius, 10 meters. I'm going to multiply that by the angle, 36 degrees, except I have to convert that angle to radians by multiplying by a conversion factor, pi divided by 180 degrees. So this is required. This is required here in order to convert the 36 degrees to whatever that equals in radians. That's the radian value now, times your radius of 10 meters. This all ends up being about, approximately, because it's an irrational number, but it's approximately 6.28 meters. Okay. So there's an example of how to calculate arc length. So now the next application is area of a sector. So let's draw this again. Here's our circle. Let's say that we have an angle like this. There's our angle. We're going to call that theta again. We've, of course, got our radius here. The sector, the word sector, refers to like a portion of the area of a circle. Basically, it's like a pizza slice or cake slice. It's a portion of the area of the circle which kind of is divided up by straight lines coming from the center, so like rays coming from the center, and then the circumference of the circle. So this area here, let's represent that area by the letter A. That area there is the area of the sector. Okay, so to figure out a formula for calculating the area of a sector, let's first remember what is the formula for the full circle area. Area of the whole circle. I'm going to call that A subscript circle, which kind of looks like A0. But that area of the full circle, from geometry, we know is pi times r squared. pi r squared, hopefully a formula you remember. So that's all fine and dandy. Now what we can do is think about what fraction of the circle does this sector constitute. So what fraction of the circle is it? Fraction of the circle. We can determine the fraction of the circle just by looking at the angle. We know that angle is how much of the circle we're talking about. We know the whole circle takes up an angle of 2 pi if you have it in radians, which we'd better have this in radians. So divided by 2 pi. Okay, theta divided by 2 pi, that's the fraction of the circle we're talking about here. So to calculate the area, I just need to take the total area multiplied by this fraction. That's all. Area of the sector here is going to be the fraction of the circle times the area of the circle, which is theta over 2 pi times pi r squared. And you'll notice the pi's cancel out, which is kind of nice. So this, if you simplify it, area equals, we're going to have a 2 in the denominator, so I'm going to write times 1/2. We've got an r squared over here, and we also have times the angle theta. And that is the formula. So there's our formula for area of a sector in terms of radius and angle. So let's do an example with the same numbers. Let's do theta equals 36 degrees and r equals 10 meters. This time, instead of calculating the arc length, we're going to calculate the area, the sector area. So this is going to be, by the formula, 1/2 times the 10 meters squared. By the way, that's going to give us square meters in our answer, which is what we want. It's a measurement of area, so it should be something squared. And then we're going to multiply by the theta, right? So far we have 1/2 r squared and then theta. But theta needs to be in radians again. So I'm going to take times 36 degrees and then also multiplied by my conversion factor, pi divided by 180, to put it into radians. And now that, multiply all that together, that's approximately 31.4 square meters. Okay, so this segment of the circle we're talking about, the arc length measured along the outside of the circle is 6.28 meters, but the total area inside the circle in that sector is 31.4 square meters. So that'll do it.